We'll look at a problem now where we're going to be loading a reasonable amount of cargo. When you're not loading that much cargo, you can simply use your TPC value and that will work out the sinkage required. But obviously, as the draft changes quite a bit, if you're loading a lot of cargo, the shape of the vessel changes, therefore the TPC values change, and it isn't really viable then to use the TPC. So let's have a look at how we do this example here. We've to load to our maximum summer draft of 6.8. We've got our length between perpendiculars 140, and we've got drafts forward and aft. And we need to calculate the amount of cargo still to be loaded. Had we been given just our true mean draft here, we could have simply looked that up in the tables, looked up our summer draft in the tables, and got the values of the displacements and subtracted one from the other, and that would have been the cargo still to be loaded. But of course we've got drafts forward and aft, so we need to work out how we solve this problem. Well, we're in salt water, so when we use our tables, we're just going to use the saltwater value. Summer draft is 6.8, so we know that at the summer draft 6.8 in salt water, our displacement finally is going to be 14,115. So we simply went into the tables and we got the value of 14,115. So let's see how we find our initial displacement, and then we could subtract that from the final displacement, and that's the cargo to load. First of all, we have to find our average mean draft, and it's simply the two drafts added together divided by 2, and we find it's 5.45. Then we go into the tables at 5.45 with the draft, and we've got some interpolation data on the right here, and we go along the tables to our LCF, and we find the LCF at 5.45, and there's the amount there, 68.88 minus 0.05 over 0.1 times 0.08, which is the difference between the two, and we find that the LCF is 68.84. So average mean draft, use that to get the LCF, then work out your trim, which is simply the difference between your two present drafts, and we find that we're 1 metre by the stern. Now we need to find our true mean draft. It should be self-evident that our true mean draft has to be less than the after draft of 5.95. We're trimmed by the stern, therefore our draft is going from 5.95 aft up to 4.95 forward. So our true mean draft, which falls between the two, has to be less than 5.95. So when we use the formula for true mean draft, it's got to be the aft draft minus LCF over LBP times trim. On your formula sheet it has plus or minus here. This has to be minus because the aft draft is greater. So it's 5.95 minus 68.84 over 140 times the trim of 1, and that gives us a draft of 5.46, true mean draft. All we then do, we use that true mean draft in between the two drafts here, get our difference in the displacements by interpolation, and we find out that our initial displacement is the 10,958 plus 133, which is 11,091. So our initial displacement is 11,091. We already talked before about our summer draft of 6.8 gives us a final displacement of 14,115. Therefore the cargo to load is the amount there, 3024. Had, for instance, them given us final drafts, two different final drafts, we could have got the true mean draft there and just compared two true mean drafts, but the second part of the problem, getting the final displacement at 6.8, was very straightforward.